Hi, this is Andre. Today I want to talk to you about this, which is a project I did in 1989, and I'm trying to resurrect it today. So stay tuned. In 1988, 1989, I had inherited a Commodore 128D from my father, and I felt the need to exchange floppy files from PC floppies to the Commodore's floppies. And so I decided to write the BDOS program, and I submitted it to the 64 magazin, a very famous German magazine, and I actually published it as a project of the month. And it's so large, they actually didn't print it like they did before. All the project of the month, they had printed them in the magazine, so you could type them in. But here they actually write it's in print. It would be over 30 pages. 30 pages in a magazine. Yeah. So let's have a look. I have recovered the sources from my old disk. So let's see if we can resurrect it.
The first step in the recreation is, of course, try it out first on the real hardware. And that's what I'm going to show now.
So let me explain my setup here. So this is my Commodore 128 on the monitor. I have AV to HDMI converter here, which the quality of which is not very good, as you can see on the screen probably. This is a XS 1541 disk emulator, and it's between the 128 and my PC, where I have the disk emulator running, so I can actually access files on the disk. And this is my 1571, which is connected here to the disk emulator. From the disk emulator, then it goes to the 128. So let's see what we can do with BDOS. So let me first load BDOS from the PC. As you can see, the activity LED here, and we load the run. Of course, it's all slow. It's all the serial protocol, and we can go here, and we have the Commodore 128. We have disk drive A, which is drive unit 8. Disk drive B is never mind. And for this test right now, we're going to use the 1571 as the main disk drive, Commodore disk drive as well. So let's just do that. Go through all of that. And we can have a look at the load file at some point. So it is now loading. You can see here a lot of LEDs. The LED is constantly on, basically, more or less, because it has to load all the operating system stuff, and sometimes it blinks. Not sure if you can actually see it. And that is when one of the other files is being loaded, because the kernel is loaded, the drivers are loaded, and then the shell is being loaded. There we go. We have the BDOS menu. And what we can now do is we can have a look at what's actually on that disk drive here. You can see it's actually my GeckoOS operating system and one file that I'd actually tried to copy before. Then we can, if you want to go to the PC, I need to insert a PC disk, and the red one is one I had formatted with that one here as well. and you can see there we have it. We even we even have subdirectories that we can create, like as we can. I'm not sure how that actually works, but so it's creating a subdirectory. Yeah, because that's the current directory, obviously. Let me go here. And we change the directory, obviously. And you can actually see the directory down here on the bottom where we currently are and where the files are being loaded or stored or whatever. So let's now copy one file from the Commodore to the PC, and there we have to first do something. We have to create a RAM disk, and for this one I'm actually going into the CLI. You could do that with this one. You can drive C format. Yes, I'm sure. And now I'm on drive C, and when I look at this, is these bytes. By the way, those are hex bytes. Those are not decimal bytes. Oh well, those were the days. Then you need to copy from PC to PC. Let's go from A. Okay, that's probably not. I didn't test that before. I had recorded some tries of copying files from the menu, but first of all, I tried it with the Commodore disk in to read the directory from the PC, which of course doesn't work. And then there are some user errors where I really wasn't aware anymore how the program worked. So you will see how that all works later on in the video when I do it in the emulator, and I'm going to show you some a little bit how the command line interface works. So here's the shell, and here you can see how to copy files from, say, from disk drive C to disk drive A. And what I did was I copied over disk drive C is the RAM disk, and you can just use copy C:\prg2.a and write it to A prg2.a, and then it's copied from the RAM disk to there. You can see we're on drive A, we can see it here, and there actually is prg2.a. It works the same way when we copy files from the RAM disk or from a PC drive to a Commodore drive. So, for example, when I do cat, I'm looking at the disk drive here on the Commodore drive, and when I do dir, I'm looking into the RAM disk, which is a PC style disk. And then I can do a save, which means copy from PC to Commodore. So I'm doing prg2.a, and then I call it prg2.a. And then it's saving the file. Sorry. And then you can see it. Actually, there is a prg2.a. And we can go to the menu and can for example, do a scratch. And then we can select the file. What the Okay, you can hear my frustration. That was at the very beginning when I didn't really know again how that worked. So, but one thing I really want to show you now is
the built-in disk editor that you can actually use to look directly into the blocks of a PC disk.
If I put in the MFM disk and then I have this one, and then I can actually use a disk editor. And here I need to break and look at the instruction. So you can actually do a read. Drive is implied, side, track sector, and it goes there, and you can actually do a mapping, and here you can see the start of the boot sector of the PC disk. And you can, so that's how you can use the disk editor, the built-in disk editor.
When I had the idea for this video, I was thinking about giving you all the details of the recreation steps that I did to actually build the sources new and so on. But that took an extremely long time, much more than I anticipated. So I'm going to just show you a kind of summary here, and I will be putting long versions with mostly the interesting stuff at the end of the video, and you can go to the time stamps that I'm putting down in the video description.
The first thing I did is I recovered basically the old versions of the BDOS source files, and the BDOS plus x64 file is basically what is on the website right now, and the other one I grabbed from the archives. Then I unpacked everything. So I had to recreate the unpack command, and because if you look into this original tar file, you will find CPK files, which is a custom packer that I created just for this purpose. So I'll be able to kind of put in multiple files, Commodore files, into one file, and also preserve the long file names inside. Because at that time I was using an Atari ST, and that had a DOS file system basically with only 8 characters for the file name and 3 characters for the extension, so I had to pack it. I had to basically also fix the unpacker because it was mangling the file names. And then I ended up with something like this, with all those lots of original source file names. And you can see here, there's really a lot of stuff there. From the original source, I then went into recreation. And so what I did, I created for each part of the archive, I created a subdirectory, and then I took those files here, and what I did is I actually converted them from the basic files, from the tokenized version, into a text version. And you can see it here. That's how the text version works. It's done. I did it with PetCat, which comes with the Vice emulator, and you can see how I actually wrote BDOS in the first place, which is basically using the Commodore Basic editor and just typing in those assembler statements and using the colon, like in the Commodore Basic, to separate statements, so I don't have too many lines. But it's not really very readable at this time. However, what I did is I adapted some of them, and when I do a make comp, I hope it actually works, you can see that it creates the output of the it takes the output of the original file which I put in here as a hex version, hex output, and compares it with the assembled version that I recreated. And if you look at the make file, you can see here I'm using the XA cross assembler to actually do that stuff there. I had to do some tricks regarding the BSS segment, because the actual code was kind of doing something similar like a BSS segment, but it was actually overlaying data with the BSS segment just to print it out into print. So there's text segment and data segment are actually 4 bytes longer in reaching into the BSS segment. So I actually had to use this adaptation for extraction. You can see how I found that out, how I basically came from a completely red diff file, diff output, into that clean output that we have here. And after having this recreation, I went into doing a real source version for that. So that's also here, and you can see here all the files have been renamed, and yeah, they don't have the version number anymore, because that's now done in Git. And what I did here is I linted them, and I actually used XA to lint them. You can see that in the long run. You can use the XA cross assembler to try to assemble it even with errors. Then use an option to not stop after I think 20 errors is the default, but just run through the whole file. Also create a print out, and then you have to cut the print out, which is actually coming. If you look at this, let me see if I can make that happen. BD1. Basically, you can do it like this. You just E that tells it to run through the whole file. P and a minus is standard out to print it there. This is the source file, and then you can throw away the error messages, and then you can cut the front part away here until here, and when you do that, you basically get a usable source file, and that's what I did here. So I created those files, and yeah, I have been editing them. Then, first of all, the original version was then also, if you make comparison now, this is actually the first one, BD plus. Oh wow, this is actually not changed. In the prompt and shell, I had to fix a couple of bugs that we talked about before, and but the actual core, the only thing that has changed in the core is the copyright notice right now. And then what I did in the end is I created this D64 file. You can just run and make dist for distribution, and then you can just run it like so on the emulator. So the error that we saw at the in the intro, where I tried to copy files with the menu, that was actually a user error. So in the meantime, I have been looking at the catalog variants, how to read the catalogs, did a lot of commenting and trying to understand that stuff, and yeah, then did some bug fixing, copy load save here from the menu, added the runme files again that were still missing, updated documents, and I'm quite confident I'm currently at a version that makes very much sense to actually publish again. So let me show you how it currently works. So when you run it for the first time, you can start the first program on the disk. That's the actual loader. So it will load the file, but if it doesn't find the configuration file, it will automatically install the configuration utility, the install me file. So this is the run me file. It finds it doesn't have it, so it runs the install me file, and there you can enter, of course, all the necessary information for the hardware. So let me basically make that larger for you. So you can enter colors, creates the load file, and we want to start. So let's make that a bit quicker. And here we have the BDOS. So what we see here, we can go to drive C, which is the RAM disk, and we need to format it. Yes, do that, and we can show it. Here it's empty and it has this number of bytes free. So now we can copy files from the CPM to the PC. And we can actually select multiple files, enter them. Oh, and that was a typo, and I have no idea if it's not. Okay, so let's try that again. That's the keyboard setting we have here. We can enter this one, drive C, insert a source and target disk, and then you can actually see how each individual file is copied. Is either in the top line which file is actually copied at this point in time, and then you can catalog it there. Sorry, of course on the PC drive. There we are. And what we can do is we can do a make directory. So do a make D1. So we see it here. We can actually enter into that one. What you can see here below the path, the current path, that's where the files go if you load them from the CBM, for example. So if I go here and try to load another file like this one, when I just enter, I actually didn't test that, I think. Yeah, but it's working and it goes to the default drive. It should be there. So if we go here into the directory, you see, of course, we are currently in the subdirectory because it actually moved there during the copy operation. And with the shift return, we can enter the directories and switch back and forth between them. And what we can also do now is copy from PC to PC. So let's see here, we have this VB file, and what we can do is we copy that to \D1. So the backslash, or here it's shown as a pound sign, says it's an absolute value. So it starts from the top, otherwise it would be a relative path. So source and target, that's done. You can see it here in the directory. Yeah, we are in the target directory, and there you go, there it is. So that is actually working. So when you are in the prompt, in the command line interface, you can basically start by formatting C as the RAM disk, and then you can see here those are the file. Well, there are no files there. You can do catalog, and you can just load a file from the Commodore drive to the PC drive, and you can use quotes to handle spaces, which are then converted to the back arrow, because on PC drives, no spaces are allowed. At least in these old DOS versions. As the very same way, you can basically do a save from the VB. No, don't ask me how I do that one. To a file on the Commodore drive. So let's see how that works out. So I have here, yeah, there you go. There's the one with the space in it. So quotes are working in that one. There seems to be some problem if both file names are in quotes, but oh well. That's a point for another time, because also there is a lot of code duplication in file name handling in the command line interface, because load, save, copy all have their own file name handling, as have rename and so on, and those definitely needs to be unified. So when there's a problem, you only need to fix in one place. Well, that's it for now. Thanks for staying with me. And if you want to have a look at BDOS, link is in the description below. Download it, you can run it, and it's the current version now. Thanks for watching. See you next time.
The next section is about running the original as I had it on the web page. There was an x64 file, which is a disk image, which is not supported by Vice anymore, so I extracted it, and this is running the original as it was on the web, running it for the first time again in the emulator.
So let me show you how it works on the emulator. We're starting x128 in 40 column mode. And you have to understand that you can configure BDOS. So what you have to do is first you have to you run an install me program. And that is asking you some question about the hardware, which drives are attached, and something more we'll see in a moment. So the first question is about the hardware. So you have the computer, you can actually run it on a, yeah, you could have detected it probably, but I didn't. You can have a drive, you can go switch through the drives, and drive A means this is the PC drive 8, and make that a little bit larger, and drive B means this is the PC drive B, and you also have drive 8, 9, 10 or 11, I think, or none, and then you can configure which drives you could use. You could, for example, use a 1541 as disk unit 8 and a 1571 as disk unit drive A on unit 9, for example. And I think no. So, and if you press yes, then the next question, printer. So you can actually say, okay, there's no other option here. No, you have to have a printer, I guess. And you print yes. You can print the IC and put it in, and then just something in there. And then what's interesting is there is the memory map, because you have three options to actually use the program, and one is through a CLI, a command line interface, like copy, where you type in commands similar to DOS commands or CPM commands from looking at files, and the menu one, which has drop-down menus, nice drop-down menus, and one that combines them both. And depending on what you select with one, you see that the memory map changes. For example, you could now use the area at 6000 hex as buffer or as RAM disk, and you can see here the buffer increases the transfer speed, and the RAM disk allows you to store files in memory, because if you have just a single drive, you can of course use it as the Commodore drive and the PC drive, but you have to swap. You basically have to copy that first to the RAM disk and then back from the RAM disk to the Commodore disk, and that is drive C. The RAM disk is drive C always. So let's with only CLI you even have some more space available, but let's do it like this. And then foreground colors, I don't care. And now it's creating a small load file. And do you want to start now? You can start now. So you can see the disk is running here. Yeah, loading files. I'm going into warp mode. That makes it much faster. So, and there you are in the menu version of BDOS, because I selected to install the menu and the CLI version together. And you can have here, you can actually see copyrights. You can change colors. You can go to the CLI, and there are some settings for how to sort the files. Then you go to the PC drive. I don't really remember what that was. So it says here it's no MFM disk, and that's correct, because Wise does not yet emulate MFM disks at all. So I didn't even try to put it there. Directory, that was, yeah, not drive. Path, you can basically, I think, change directory. You can make dir, delete dir, and so on. If you go, we can go to format, and then we go to input drive and name of disk. So if I are you sure? Let's see. So we now have an empty PC disk here. Yeah, nothing in there. So now we have the Commodore file, and then we can have catalog, and we have those files here, for example. And then you have to use Control-C, which is the run stop key, to get out of that one. And you can of course use scratch unit, change units, and so on. So you can copy. Now let's copy something from the Commodore to the PC, which only works for the RAM disk right now, because I don't have a real one. Search mask. So let's see. This is one. Let's try this one. And then we go to drive C. Insert source and target disks. Type enter. And now it should be doing something. But it isn't. Okay, let's try again. Okay. Drive C. Name not found. Oh yeah, interesting.
What I resurrected from my old archives, which have been basically archives from my Atari ST that I then archived on Linux and put on some archive disks, and that is what I found now. That's a tar gz file, a compressed archive, which I created on one of my first Linux machines, I guess. And that's how we can start recreating the source.
So let's unpack it. So only a couple of files in here. Let's see. So put that one level up because there's nothing else in it. So let's go here. By the way, the plus is coming from where I actually added some stuff after publishing, after getting the permission to publish. So what's that? We have zipped files in them as well. So let's unzip them. So, but now we have CPK files. So what is a CPK file? A CPK file is a very simple packing format that I used when I was archiving my Commodore files on the Atari ST. Because the Commodore, you have strange characters like slashes and long file names up to 16 characters that just don't fit onto the file names of the Atari ST. So I created a small archive file format, and that's what I used here. So let me get the unpacker. As you can see, I have already prepared something, and interestingly, there is I had found this old C implementation, no comments, but yeah, well, it works. Well, it actually kind of worked, because then I found an error here. If you can look at the diff, you can see that here the file name was not it was actually trying to unpack the slashes, so that wouldn't work, and I have file names with slashes in them in these archives, and also the file name was not zero terminated, so the longest file name basically won, and you had some longer file names here. So but this one is the right version, and there is a compiled one. So let's go to these folders. And unpack that stuff. Bang, there you have it. Quite a number of files, and basically this is one disk, as far as I remember, on the Commodore. So basically that's why there are actually 4 archives in here. And you can see that's the binary distribution disk that I have here, and yeah, you see a lot of programs. You see a lot of programs here. Warum habe ich das jetzt eigentlich so gemacht? So let's unpack the others. Here you can see the first source disk, and this is basically the kernel of the BDOS disk operating system, or whatever you want to call it. This is the second source disk, and here you actually have the prompt, or the Windows prompt. Windows prompt. So we'll have a look at how this works. So after unpacking the sources, we can go in here and have a look at the instructions. And there are 6 files that are on the instruction disk. And yeah, you should not open it up with Ocular. You should open it up with KWrite. And there you can very nice. The magic IBM, the magic word in terms of compatibility. You have a Commodore 128 and a 1571. You always wanted to take your PC disk from your business back home and work with those files. Now you can. Well, what did I write there? So interesting what we can see here. Umlauts, that's German, of course. Not here because that's a special mapping. I didn't immediately find a mapping on the PC. And here are the different commands that are in the command line interface, and you can change the file number, and here are some examples of how to actually use the commands. And so this changed. I don't know what those spaces are. Probably they are tabs or something. I'll have to look into the hex editor, into the file, and then you can yeah, what we see, that's interesting. Well, I have to have a deeper look. Then there actually is a special command, and you have the buffer, and that you can use as disk image, as disk monitor. So you can actually run change if the image, check the media change, gets the BIOS parameter block, which describes the format of the disk. I think, if I remember correctly, you can read write depending on track and sector. And here you can actually read write depending on logical sector number, which is continuous series of blocks on the disk image, on the disk. And then you can actually write out the buffer. Some names, system. With system you can actually load drivers, additional drivers into memory, I think. That was so. You can, there's some example with multiple disk drives. Whoa, that's open with. And there is the menu. No, let's see what did we do wrong. So you can actually see here the description of the menu entries. So there's a lot of documentation here. So you can read, you can show a file on disk, make directory. It's all what we saw here. And then we can do the copy. Copies from Commodore to PC disks. The file name is being cut off after 12 characters, and the 9th character will be a dot, so that you can actually get the 8 characters dot extension, 3 characters extension file name. Yeah, I don't know why that didn't work. So let's have a look here. This is the 64 hardware, which is actually, yeah, there used to be a schematics. The schematics is actually in here, but the one that's in here is broken. I accidentally put in a wrong connection. You should never use it, because it would 5-volt directly onto an IO pin of the CIA. So there you have the description of the files. Man, did I write documentation. So you have the run me, that's the actual start program. I didn't show it yet. There's an install me that I showed. There's a loader that actually then loads all the rest. This is the configuration file. This is the main program. And this is the main program that I think should work everywhere. No matter if you're working on a 64 or 128. And then this is the, interestingly, there's only one version for the 164 and the 128 at the same time. Then we have the 3 program versions, one with the command line interface and menu, one only menu, one only command line. Oops. And then there are the drivers. And as you can guess, you have the V driver for the video whatever. It's the RAM disk for the 128 and the driver for the 1571. And then you have the C drivers for the 64. And there's the RAM disk. There's a driver with the for the 1571 with the hardware. There is memory access and only for the C version, for the CLI version. I have no idea why that is the case. And you have the okay. This is only the memory access. This is memory access and screen driver, because of course the menu actually uses advanced editor functionality of the Commodore 128 editor ROM, and the Commodore 64 doesn't have it, so I reprogrammed it here. And then with the program install me, you create the configuration, and then that's what we've seen. And then you have the different, that's a lot. You can see the list of programs with start address, length, and used memory areas. Program Anfang, which means begin. Begin of program memory, the end of the program memory, the variable, begin of variable memory, end of variable memory. And then you have the buffer. And then they have some parameters. I have no really idea what I wanted to say with this one. Okay. In the RAM disk, the RAM disk is being separated into tracks of 2 kilobytes. Every one of the 32 tracks in the C64 or 64 in 120 can be used for RAM disk separately, I think. That's where you can actually give a list of 32 and 64X and to a routine, the highest bit and so on. So memory map, okay. There's some, yeah, I don't know, footnote, but I don't know where from. Memory map. So you can right. Those are the parameters when you run those programs, when you load those programs, I think. This is something somehow. And then you can actually tell this program which memory to use. Oh wow. Open with, so what we have here. And that's the instructions for programmer. You can use 2 parts, prompt and DOS, BDOS. Prompt is basically the shell. You can have it in CLI and menu, and the BDOS is basically the kernel with all the kind of operating system. Optional RAM disk. Prompt version 2.1. So so to start it, the to start a program, BDOS must be installed. Then the program is being called with the start address. Calling from basic is not possible because BDOS is expecting a memory configuration where there is no basic ROM. Of course, that's why the loader is there. BDOS is the actual operating system. To be compatible with later changes, all routines are being done over jump table, where most of the jumps are indirect. That is an address table. And then you can something general in front. All routines give an error code. On error, the 0 flag is cleared, so you can do B and E in machine code if there is an error. They're actually written here. And the accumulator has the error code if you run into an error. Table 2, there is a routine address relative to start address. How's the disk set up? So we have the W1770, which is a disk controller in the 1571 standard product. Yeah, Atari ST used it in similar form. I use it in my Commodore PET clone, and I actually have a recreation of the 1581 3.5-inch floppy disk that I also uses this chip. And then there's some technical detail, numbering. Side 0 is underside, side 1 is bottom side, and side 1 is top side. Track 0 is from the outside, or track 40 on the innermost track. Sector 1 to 9, or 8 or 10, depending on the formatting. So the controller has a command query where it's actually looking at the different disk format, and then you can have boot sectors and stuff. There's lots of stuff. This is the formula for the logical sector number. Remember, I noted there is a command to read a sector not just by track and sector, but here you can actually have the logical sector number. The routines. The system group. Init, exit, query. Get the format. Media, check if the media has changed. Get the disk parameter block. Or BIOS parameter block, I think I called it, or BDOS, I don't remember. Flop read write is, I think, the track sector addressing. RW ABS read write absolute is the absolute addressing, and then there's a format and there's a version, and that's basically what you need to have, I think, from the disk driver. And then that's actually all you need for a disk monitor. But to actually use directories and so on, there's the directory group. Couple of stuff. Well, I guess there's search first, or I don't know, search next, change it here, and so on. And then we actually have the cluster stuff, where we can get a new free cluster. We can free a cluster, and we can get how many clusters actually free on the disk. And then we have the file stuff: open, close, read, write, seek. Cool. And then what's in the last one? The RAM disk. Oh, okay. So basically what you see here, this is what the RAM disk provides. And yeah, basically it patches itself in, and the other program, not just the RAM disk. The RAM disk patches itself into these system calls, via the jump table. And this is a small program, show read write absolute. It puts itself into the read write absolute call and shows every read write access in the topmost line of the screen. And then it waits on a key press, so you can actually follow every read and write. But you need to have a free space that you need to have in the loader. When you set up the system, you have to have that free space. Same here, but you can see the track sector. And this is a small program. How to extend the prompt with, or the shell with, system files. And this one also shows a directory with those two: search first, search next. Actually, nice nice letter to the editor. This source code should be printed. In Commodore 64 modus assembled, this can be loaded into the system and then used for the shell. Similar here, how you can actually do parameters. So, well, you can obviously give parameters to the system programs that you call, and that's actually how the the loader stuff loads everything. So what have we here? Of course, the copyrights, and an error message list. There is a short description of all the routines of the system, so you can see here the basic floppy stuff, directory, cluster, change it, and make there, and so on, seek, lots of stuff. Actually, as we can see later in the source code, there's some more, which are coming from the screen handling, because I had to do that for the menu. That's actually a Commodore DOS boot sector. So you have those 8 bytes jump to the boot program of the IBM PC. Then you have serial number, byte per sector, sector per cluster, protected sectors, which I completely ignore, it seems. Number of FATs. Typically a DOS disk has 2 FATs. File allocation table, which is kind of equivalent to the BAM, block availability map, on the Commodore 60 on the 1541 and the other Commodore disks. Only the link pointers that are in each block on the Commodore disk is here in the file allocation table as well. Number of entries in the main directory, total number of sectors, sectors per FAT, sectors per track, number of sites, stuff. And this is what the BDOS makes out of it: BIOS parameter block. So stuff like that. There's another table. Disk transfer buffer. I don't remember what that was. Yeah, I think it looks like somehow name. So it looks like something in the where to transfer the file, the information for a directory. File parameter block. This is the actual directory entry. Wow, I had time to write documentation those days. There's all the routines with, yeah, input, output stuff. A reference, a real reference. Isn't that nice? You can actually, the version one is really oh, you can have a reset chain, IAQ chain, and NME chain not implemented. You can actually have the time alarm. And that's the zero page usage. Wow. That's quite some documentation. I probably cannot read it anyway. Now let's have a look at the sources. And yeah, as you can see here, I'm in the source disk 1. You see a lot of those files here that have this S and the double-digit number. And because I was really bitten hard by the overwrite bug of the Commodore disk of the 1541, where if you use the overwrite command with the @ in front of the file name when you save a file, that could basically corrupt your block availability map. I was really into saving everything with a new version number and then increasing the version number, and that's where all those versions came from. So you basically have a full version number, and then you have a, I don't know, today it would probably be a commit tag, and we'll have to have a look at what's all in there. So source 1, as it seems, is the BDOS, the actual operating system. What you can see here is it's all BD, and then there are some short names. We'll have to see what that actually is. CB is the driver, so you have the Commodore. B probably means Bildschirm screen. I don't remember. That was in the dock. CD, disk driver with the hardware for the Commodore 64, and then we have the 128 drivers here, and the demo programs. And so how did I do those demo programs? So let's have a look. And when we go to one of those files, that's actually no, I wanted to go to, that's actually the main program. But if to the source file, it's still unintelligible, but you can see here there is some text in there that you can probably understand, so some assembly text, but it all comes clear when you run it through petcat, which basically decodes a basic program on the Commodore 64 here. And you can see this is basically a basic program which has assembly code in it, and very compact assembly code, multiple commands in multiple statements in one line, separated by colon, like you know it from BASIC. Lots of cryptic labels, no blocks whatsoever, except for some separating comments here like that. You can see here, okay, this is I guess this looks easily recognizable. That's the exit jump. So let me see, which would probably be the main one. If it's not BD1, is it A? That is actually the first one. And you can see here how it was assembled. It was assembled using my assembler. I hope that doesn't get cancelled by YouTube. At assembler 1.1/7. So, and the /7 means that's loaded into 7000 hex in memory. This is all commented out because I usually had that in memory anyway. And what you do is you open a file, and that's the output file. You jump into the monitor, and then you do an opt pseudo opcode, and the O says which file number, file handle it should use to actually write the output to. And because you could write the output to memory, but O1 says write the output to the open file 1 and the file that has been opened here. And then you have the version, some other commands, and then you have a lot of includes here. I have no idea what that hash is here. 1270. I really have no idea what that is doing. And then you can see include unit 8 file name this, and you can see it has a lot of overlays, as it seems. And then once you are there, you go to 150, 140, 60, depending on that hash sign, where I have no idea what it is. Op means printing, and then you can actually get a listing. Yeah, it's really strange. And then you get a listing, I think, on screen, because there's no file number behind it, and then you can actually see the output of the variables. Yeah, so let's then what we have here: K constants, S structs, struct definitions, J jump tables, and then there's the actual code. BDOS, I don't remember that. There's a lot of, that's the actual code in there. There's K. So those are constants. Like, for example, here, kernel routines, addresses of kernel routines, addresses of pointers, whatnot. Then we have S. S is structs. And then you can have here the different types of structs. They all start with the same short code, like VE for version, PB for parameter block for floppy read write. So you have a block where you can give the command the read write flag, and then lots of stuff. For example, you have BDU just as a random one. Oh, yeah, random. Yeah, it's not. Wait, it's not really random. I guess it's utility or something, because this is arithmetic. So it's a division and a multiplication. And what have we here? BDR ROM stuff. I don't know. Was that actually in the loader table? So I guess A means Anfang. Oh, oops, that's the wrong one. That's B. I don't know. Yeah, it's gonna be nice getting that to work again. I'll probably start. So BDR, no, the BDR. Oh, actually they are there, but I don't know. Yep, because of course the Commodore 64, where I built that stuff, doesn't have that much memory, and so I had to keep it short. I had to work with overlays and output files, and yeah, it's gonna be fun looking at how we make it actually compile. So this is a small program. See, this is a screen driver, I think. So setting some vectors. Home, jump home. Where's home? Set cursor. Yeah, it looks like this is really, and that's for the 664. So we have quite a number of pages, 15 pages of screen driver. And when I go to the VB driver, which is the same one for the Commodore 28. Oh, it's still 11 drive. It's still 11. No, it's more than set screen. This is different. This is actually something for drive. What did I say? Oh well. Naming not. That's actually a floppy disk driver. VP, strange. And VD. That's also something on the floppy disk. Yeah, but anyway. So the goal is to recreate the build process on the Commodore 64 emulator and see how far we get, and then see if we can actually port it to a modern cross assembler and see how far we get with this one. So what I did was I copied the AT assembler here because I found it, and it's actually on my website as well, basically next to BDOS. And now let's start x64, the emulator, and let's do a setting here because I want to use the drive type directory, and then we can have here I'm so not used to that anymore. Okay, let's do this, and there we have ATS7. So what we need to do is we need to basically what we need to do, we need to delete this target deliverable target file. Oh man, is my day job bleeding through? So, and then what we need to do is we know BDA. I'm so not used to that anymore. So and then we load the ATS7. So, and now let's see what happens. Undefined statement, go to in 1000. Okay. Yeah, I guess because I renamed that stuff after doing that, so it's, or maybe that's that one. Syntax error. Okay, BDK on 41S17. BDK 141S17. Oh yeah, of course, it's lower caps and I have it in upper caps. Okay, need to do something. So Stack Overflow to the rescue. There is a little program, a little script that can actually do that. Put all files lowercase. And let me see. Yeah, that looks good. Now, and what you can actually see here, it has already created the file. We just have to remove it, because then it'll probably give us a file exists error. So let's get back to the emulator. 12 drive settings. We go back to directory. BDA Stern gemacht. So then we know we have to insert the 0 here. Don't forget to press enter. So it's all changed. And that's it. We just type run. Oh, run, I mean. Oh yeah, that, of course, I forgot. It's now ITS 7. Okay. Run. There we go. It's not that bad. I can think that on the real drive it would be a tad bit slower. That's not warp. But it's still there. So let me put in warp mode. So it is a bit faster now, but as you can see, it is building. And you can see the output from the last one, the op P, as you can see. This one is, I think I remember what that hash is. I think it's the pass. And there you can say, okay, I only want to print out that in the second pass. I think. Well, so let's see what it actually built. So we got a new file, and look at this. The files are identical. Yeah, we built BDOS from sources again. Very cool. So the next step will actually be taking the ASCII output files, the list files, and yeah, format them and convert them into inputs for a modern assembler. What modern assembler should I use? Of course, it's the XA65, and the reason for that is because it was specifically built to digest those source files, at least when converted to ASCII, like PetCat did just for us. So that's the reason why comments cannot contain colon in the default mode so far. That's going to change in the next release, because it really is annoying when you're doing modern type of development with one statement in a line. The pseudo opcodes have been changed, but I'll have to have a look and how to see what I can do with that. And the idea is then to actually create the very same binary that I had on the Commodore. So let's get started. So I created a new folder where I put the source files then separately, and I could put in a make file, and I copied over the first file here, and yeah, I'm gonna rename it in A65 because that's the standard extension here. And then let's see, We have to remove all this stuff. We have to remove this one, and file if. I have no idea how I do that actually. Yeah, probably I don't need that, because it says if in the second pass go over the constant and the struct, because they don't generate code. They only define variables. That's saving some time, but we don't need that here in this time, and we need to change those ones into. I could have used preprocessor include, but recent versions of XR have also learned to use a pseudo opcode for include. But now what I remember here is no unit number. So if then go to if pass 2 go 1460. Now the good question is, so I have a, that's XA, so let's uncomment this one for now, and until we have found a bit more of that one, what that actually means, because I guess there will be something more. So then we have a makefile. Let me, yeah. So BD plus star.a64 XA. Okay, BDA. Let's do it this way. Names O output. Where it should go. Input this. Make. Okay, couldn't. Yeah, right. Spaces in the file names. That's always not a good thing to have, but it was usual in those days. BD plus is up to date. Okay, remove BD plus. Make. Okay, final folder. That doesn't look too bad. It's already trying to include that stuff. So let's copy BDK listing here. Okay. Move BDK to BDK A65 value BDK. That's actually semicolon is a comment anyway. There's no dot end. Make file not yeah, of course not. Move BDK. Let's just do it this way. Okay, first one went through, because you don't see it here anymore. As you can see here, there was BDK was not found. Now that's cool. Copy over the next one, BDS, the listing, BDS, okay. Oh, if program go to 1620. Yeah, the reason for this is this file has the jump table for the actual program, and yeah, let's put that here and make it if PRG, no, if one, and then because I don't have that one, and if you run it in a file, else if you run it in a program, it actually just defines the variables. Okay, there, of course, as you can see here, we have the colon, and we only commented out the first part, but not the .goto. So let's see if that helps if we add the appropriate option. Yep, next one is through. So what you can see here in the pass 2, it already does not find some of the variables. And again, there is a syntax error. Okay. What do we see here? BD3 in line 1960. No, sorry, 90. Okay, I'll fix it the other way around. So there's this go-to jump, and let's comment that out as well. It's probably the better way to do that. So we have BD3. Still have that syntax error. That looks very strange. Anyway, I can just do this, and it's still there. Oh, dot is missing, interestingly, for whatever reason. BD4. Okay, here we have some interesting stuff. There is a .if and a .goat. Wow, 150. That looks like a strange thing to do. There's syntax error that was expected. Table of offsets for the BF1 files, the data. I have no idea what that means. But that's giving me a syntax error. A strange one. Let's comment that out for a moment. because that is really, really strange. Okay, so let's look at things we commented out here. I guess if in path 2 we need to go to 1460, which I removed. So, but I guess I need to do those as well. And I need to remove the end if. Oh, RAM files, that doesn't need to be initialized, so that's actually BSS. Interesting. So that could be something where I could work with the new assembler directives and the new stuff like relocatable file format and stuff. I guess that's a loop to actually, we'll have to see. Those loops here are actually something where I have to look at let's do it this way. And here I have to do a .bss. BPB minus BPB len. BPB is the start. Actually, BPB len comma 0. So basically, what this is calculating here is the distance between this one and the current program pointer, and if if this is not 0, it goes into the loop and just adds a byte, and the only thing it will end up when we have finally added BPB len bytes. So let's maybe go back to the other one and see if I can fix that as well. That is embarrassing. Here we have a safeguard actually. So, but yeah. Point assert. I think it's assert. Buffand minus Stern größer 15, actually it has to be the other way around, I think. Table of offsets for, wow. What is buff uns? I don't have loops in that yet. Number of buffers is buff uns. BDA 4. It's actually 4. Okay. That is a nice thing here. Oh yeah. Oh, that's gonna be nice. That's gonna be interesting, because I think I have no priorities in the arithmetics, because then that makes sense, because that takes the distance between this one and where the byte is assembled times the BF offsets, and that would actually make sense. Well, and that's probably why I have all those brackets everywhere, because mathematics. But on the other hand, so what I know is the first one is 0, then the second one is this, then I have 2 times, no, it's dot byte BF offs, but 2 times BF offs, but 3 times BF offs, and we have 4 buffers. So we have 0, 1, 2, and 3. Okay. Oh, it's still a syntax error. Line 23. Okay, maybe just do it like this. Okay. It's way larger than what we had before. So let's see what we have here. We have a lot of stuff that does not need to be initialized. So let's take that out of the equation. So let's go make file. We go into relocatable mode, and then we go BDA. Actually, I can do, yeah, okay, that's a, I can go there and basically say that this is .bss. No, actually this is still .bss. Subtracting pointer from constant. Let's just ignore that for now. Now we have a O65 file that has all the necessary relocation information inside. So let's see what we have to do. So I was testing a little bit, and now if we look at file name here, it's 7799, and we have a file that's 7790 bytes long. So what I basically did was I created the file in relocatable mode, and then I relocated it with the minus capital X option that extracts the text and the data segments without the BSS segment. But what we could also do is we could also have a let's do get some info, and for that we do a file 65. We do it verbose. Oh, by the way, we want to have bd plus.065 for that, and give that here, make info, and we can see here we have the whole program here. We have the data segment, which is empty because I didn't put anything in here. We have the BSS segment, which we have to relocate because that's var unf in the BDA file, and zero page. We don't have a zero segment because all zero page addresses have been defined as constants and are basically directly copied into the code. Now the question is, where are those line bytes coming? I have a suspicion. X dot minus C BD plus. So let's see what we have here. And then we go up one and we do a hex dump minus C BD plus to ED plus dot hex. So we go here and we do a diff of BD plus to B dot BD plus dot hex. Sorry. I wanted this one, right? Yeah. And yeah, that doesn't look good. Oh my, it's already there. Okay. So we have to find a more intelligent version. So I was looking into how to create the file in relocation mode, and the last time that we had was we basically did the XA assembler and created a output file in relocation mode, which is this command line option here. I also added a print listing, so you can actually get a more readable formatted listing out of the build process. I also looked at, I think you need a more decent variant of the software. I'll have that, I looked that up exactly what is needed, if it's in 2.4.1 already, which is the newest one, which is not yet probably in all the Linux distributions. So probably have to get it from the from Cameron's website, and then you relocate it and extract it. And then what you can do is I can run it, and I have a real, basically total list of difference. So, however, some of them are there. So you see, for example, the 6C, which is the jump indirect, or the 4C, so it looks like there is some address mismatch here. And so what you can see here for the first, in the first one of the 4CFB A7, and it's here for CFD17. So this is text segment. So basically what it shows is that the so this is the compiled version on the right hand side. It shows it's not at the address that we actually load to, because that should be something in the A7 range here. So then therefore I need to modify the make file. And the first thing I did was, and I'm adding this here, adding the text segment, and was that. So it starts at A00. It's not really much better because, yeah, the A is now there, as you can see, but it's still, yeah, two addresses of 2 bytes off the address. Yeah, and the reason for that is, of course, I forgot about the load address. A common mistake. So you have to actually subtract 2 of them here. And then, yeah, we're getting better at that. So, but now we still have, still have a lot of errors here in this addressing. You can see here the indirect addresses are going to somewhere in the original 1102, and this one is somewhere at BE78. And the reason for that is because that is basically a jump vector address. I can go into the code for that. If you go into EJ, you can see here, you can go, this goes over vexit, vquery, and so on. And now let's find out where those addresses are. And those are in the BDDJ file. So here are the addresses. And if you look at the BDA where it's all assembled, we can see that the BDDJ is in it's this one. And you go to the modified one. It's in the BSS segment. So the BSS segment is not at the right address, and therefore we have to move that also. So we go to you set the base address of the BSS segment, and this one is let me look there, which is basically 110. If you go at this one, you can see here var_unf. Basically, that's where it should be. It's 1100 hex, and that is 4352 decimal. So we look at the diff again. It's not yet there, and it took me quite a while to remember. The reason for that is the relog code to extract the file actually with the -x option. With the -x option resets those addresses, and I have to overwrite it again here as well. So if you look at this, this is looking much better now. We do have a number of strange things here, but then we have something that's happening here. So yeah, first let me explain a little bit here about this one. What we can see here, we only have a text segment, which is 7,800 bytes long, and we have a BSS segment, which is 1,311 bytes long. So there is no distinction between the text and the data segments, which I could introduce, but I haven't now, because I want to really make a byte identical copy. And the -x option takes the text segment, takes the start address of the text segment as it is in the file here, which is, as you can see, a 9FFE, which is 2 bytes load address, and then we are at A000. Then it puts the data behind it, which is nothing. And if you scroll up a little bit, we can actually see that before we put the BSS segment directly behind the text and data segments. So, and that's why we have to actually add the BSS segment address here again. So let's look at the diff. So what is strange is because here we see we have something that is it seems to be really 1 byte offset, and that seems to be this one actually. If you look closer, you can see here 2E to E to E, 2E to E A2, and yet it's 2E to E 0 A2. Now, how do we find out where that is? So we remember that address 14D0, and then we go to the code again, and we look at there it is at the listing, and the listing you see it. It's somewhat much more readable because you have all the you have all that in a one statement per line, comments put in the right place, and so on. You even have all the address, the segment, the address, and the bytes that are rendered out, and so on. And it even tells you at which file there is. So that's a relatively new feature in XA, which has come in there in version 2.4. So sorry again, 14D0, adding the start address of A000, which is then B4D0. So we can B4D, let's try it this way, B4D00. We have here this make D root. So let's look for where that is. Wait, did I type? Okay, here we go. It's in BD3. So mkd root. So, and here, why is that strange? This byte is extra, and the reason for that is because in the original one, when we look at this one, BD root. Sorry. Yeah, that's the right one. mkd root, sorry. We see there's actually a typo. And yeah, I said, okay, maybe that was actually rendering like a byte. It isn't, obviously. As we see now, so I save that, and I do a make, and then we can do a diff again. Wow, and that looks much better now. So that's really cool. And the only thing here now is a topic that is coming from character set conversion. You can see here it's in uppercase in the original, and it's in lowercase in the new one. And the reason for that is because, of course, the old assembler is all PETSCII. And therefore, we can actually add a output option for PETSCII. Let me look that up for a moment. Yeah, it's -o PETSCII. Now the only problem is if I do a make, I get this problem because all the files, because that's an include, which is more or less a native assembler statement. This is also doing a PETSCII conversion. And therefore, what I have done in the original one folder, I have renamed everything to uppercase again. I do a makefile. And then kdiff where was that? Yeah, this one, and BD plus. Sorry, kdiff 3. Okay, sorry. Binary equal. And I can even go for the hex versions. That's what I actually wanted to do. Again, you get binary equal. Here we are. An exact copy of the BDOS kernel created with the new, with modern toolset. Cool. So to give you an overview on what I had to do with the second part, with the prompt and shell, I'll give you a quick overview on the diffs that I had to do in the source code. So this one is actually the same as in the kernel. It's an error table, and you will see we have quite a lot of those .if, and then there's a flag, and then the original assembler had this if statement, and then everything behind the if statement in that same line would be executed. And here it's an .end. That doesn't work without an end if in the new assembler, so there is a .if, and then the flag is inversed, and you get the end if here, for example. And we have it's also the jump table, basically the same thing. Then we have the constants, which is completely the same. We have the structures, that is completely the same. They are just included in as definitions in the prompt, so they can actually use those variables, those constant names. And we have the first version and the first part, and as you can see here, there's a lot of this stuff that I had to rewrite into basically such statements, and I've also put that out into single lines. Then there's quite a number of these if statements that I had to do. Let me see if there's anything special. No, it doesn't look like. It's all like those if statements. If statements again. Some if statements again. Here it gets interesting because here we have that backslash. That actually was escaped by the assembler. I'm not fully sure what is in the original. I would have to look that up. But the assembler actually said, yeah, there is this. It was trying to render a quote, a double quote actually. So I had to fix that afterwards. That was a single byte change. And what we have here, some ifs. That's that. And we have that's the main part. I removed the load file for the assembler. Then we have here the different options. We have 3 options, so you can basically you could create that's 6 versions, and I think all 6 binaries are on there. I only have checked one of those so far. So if you set here f menu, fmn, if you 1 it's without menu, fci as a flag for the CLI, it's 1, it's without the CLI. If both are 0, like here, we have the menu and the command line interface, like I showed you in the introduction. And then you can actually switch between English and German. And here we have some, the buffers are on different addresses. That's something that's probably needs to go into some kind of make statement or so in a final version. Then this is the include we talked about. And even though the names are here in lowercase because the assembler does it converts it to Petsky, it runs in uppercase. And here we have the same structure with the BSS segment, the variables that are not included in the file, but they again are here added at the end of the binary. So that's that. Some if statements. That was quite a bit more than in the original. Here we have something that now it gets even more interesting because we have all those command names which are encoded in Petsky, and the PetCat has rendered them out as lowercase, and the last one was uppercase, and that rendered wrongly in the assembler. So because in the end it was actually lowercase plus 128, so setting the bit 7. So I had to reformat that one. And there's an if again. Actually, there's some support for RS-232. I have no idea what's in there actually. So, but yeah. Here we have some other things that took quite a while and quite some work. When you enter a control character in the Commodore editor, you get those inverted characters, and those are basically directly stored as the control character, like here for a clear screen, which is basically 19 plus 128. Home is 19 and a decimal, and adding the upper bit makes it shift home, which is basically clear the screen. Same here, and then we have that here, a whole lot of stuff like that. We have cursor right, cursor left, cursor down. So I had to fix all of that, and those are the German text file, obviously PRR. I think there's PRRE is then for English. Not sure if I have. I don't remember right now if I've actually changed that. So we'll probably see in a moment. PRRE. I actually have changed that as well. As you can see here, I fixed that as well. Yeah. So, and here we have all the, so you can see here, this is the input search mask and so on. So that's how I did the translation. Yeah. So those were the changes that actually made it build on the new assembler. Now that we have been able to recreate the binaries all and with the original source file, we should be looking at how to lint them and to make them more usable for modern toolset. So currently the recreation files are still named like so, the old ones, and the format still is, as you can see here, line numbers, multiple statements in a line, and so on. So that's not very usable. How can we do that? XA to the rescue again. We can use XA and use the -E so it doesn't stop after 20 errors. It does a -P to the output, and basically you can see here it's printing out some lines together with intermixed with error output. We can move the error output away. using this one, and there we have basically a listing, almost usable, and we can just cut away the part in front, and then there we have basically a useful file. I've already done that, and here in the other folder that's now called source, because this is the place where it should go, I have renamed them. I have removed the version numbers because versioning is now going to be done with Git. And when I just run one of those, open one of those files in an editor, you can basically see there's a nice syntax highlighting triggered by the file ending, and you can build it. You can compare it to the original, and yeah, we get the right one. So to make sure that we have the very same output that we had before.